Hello pre-calculus students, and welcome to a video on mathematical models. This is part one of either 2 or 3 videos that are going to show different types of problems that involve modeling. Okay, so first, in order to complete this, you do need to know the distance formula, so why don't you pause the video and write it in there, hopefully from the top of your head without having to look it up. Okay, so there's the distance formula, the difference in the x's squared plus the difference in the y squared, all underneath the square root. All right, so what this says is we're looking for, the topic here is the distance from a point to a curve. And what we're going to do is we're going to make a function that expresses the distance from a point to a curve as a function of the x value of the point. All right, so let's look at what we have. So we have a point, we're going to call it a random xy, is a point on this curve. So we're going to graph this curve in a second and just pick a spot and call it xy. Okay, and we're going to just express the distance d from that random point, which is really a variable point, to a fixed point, 2, 0. And we're going to describe that as a function of x, and then we're going to solve it for one value of x. We could solve it for any value once we have it. All right, so let's start out with just a sketch of the curve that we're talking about, y equals x cubed. Kind of get a visual of what we're talking about here. So we have 0, 0, 1, 1, negative 1, negative 1. We know the general shape of the curve. Okay. Now, we're going to pick a point on that curve, and it could be anywhere on the curve that you want. And why don't we just pick a point like right here? Maybe that's negative 1, negative 1. Maybe not. It doesn't really matter because we're going to call it xy. All right, now we have a point that we're specifically looking for, which is 2, 0. So if this is 1, 2, let's call that 2, 0. And now what we're looking for is the distance from this point to the curve. Now, at the place where I put the point, that would be the distance, okay? And if it were negative 1, you could just plug those numbers in the distance formula and find that specific value. If I put it here, though, it's going to be a different distance, right? If I had chosen this point, it would be a different distance. And the idea here is that that point can be anywhere on this curve. And the distance from 2, 0 to the curve itself changes as you move along the x values. Okay? And we're going to see that now as a function. And here's how we're going to do it. We're going to use the distance formula, but we're going to put variables in there for this. Now, we know that this is 2, 0, and we know that this is xy, but that's too many variables. So we actually know something more about this, because we know that this is the function f of x equals x cubed. In other words, y equals x cubed. So I'm going to rename this general point, which could be anywhere on the function. I'm going to rename this as x, comma, x cubed. Now I've got just one variable. And that allows me to take this point and this point and plug them in to the distance formula. So what I'm really going to do is I'm going to call this x1, y1, x2, y2, and just put them into the formula. Okay, so let's do that now. So this is going to be the distance as a function of x. So the distance as a function of x will be y2 minus y1. Now it really doesn't matter which order you go in here, but I'm just going to go in the order we have. So x is first. So x2 minus x1. So it's going to be 2 minus x. This is all inside of a square root. So 2 minus x squared. Again, I'm just applying the formula. Plus the difference in the y's, which is 0 minus x cubed. 0 minus x cubed squared. And that is the function. That's the function that will give us the distance between this point and this curve, wherever we are in this curve. Okay, now let's simplify this a little bit first. So we can multiply 2 minus x times itself. And just here, let's pause. I'm going to simplify this and then I'll show you. Okay, so there it is. Using the simple multiplication here, just multiplying 2 minus x times itself, and then putting the function in descending order. Okay, so x to the 6th plus x squared minus 4x plus 4, all inside radicals, gives us the distance from the point 2, 0 to the curve y equals x cubed as a function of x. Now I'm going to find this distance in 2 ways. All right, now let's just hypothetically say that I put this point here at -1, -1. All right, because if x equals -1, we know that y equals -1 on the cube. So let's say that this were -1, -1. We could apply the distance formula the old way, right? Which is to find the distance from this point on the curve to this point that's the fixed point. So the distance would be the difference in the x's, so 2 minus -1 squared, plus the difference in the y's, so 0 minus -1 squared. And that would give us what? This is 3 squared, so that's 9, plus 1, that would give us the square root of 10. Now let's try it in our new function. So d of -1 would give us the square root of -1 to the 6th plus -1 squared plus 4 times -1 plus 4. Let's see what we get. So we have -1 to the 6th is 1. -1 squared is 1. 4 times -1 is, oh, this is supposed to be a negative here, sorry. -4 times -1 is plus 4. And then plus 4 here is a square root. Okay, so this, I just carry this subtraction down, but that's a negative. Okay, and that's the same thing, right? Square root of 10. Okay, so what I want to look at really quick is what would happen if we graphed the distance function, the function that tells us the distance from the point from the point 2, 0 to the graph of y equals x to the third. So I put the function in here so we can kind of see it and see if this makes sense. Okay, so I'm going to just hit zoom 6 and see what we get here. And there's the graph. And it doesn't really look like anything familiar. It looks kind of like a parabola, but clearly not a parabola. It doesn't look like it has symmetry. And now let's just think about this just a little bit from the perspective of what happens if x equals 0. Well, if we know that x equals 0, the distance is super easy to calculate, right? It's just 2 units away. So we can look here and say, what's the output when x equals 0? And you kind of have to zoom in a little bit, but you can see it. And it goes right through 2. And we could find the y-intercept pretty easily, but we can see that it goes right through 2. Okay, and it will work for any point. And by the way, here's a tool that I think I've shown you once, but maybe kind of quickly. On the top row, one of the things that we never looked at in the top row is the table, or we looked at it very little. So let's take a quick look at the table. So second table tells us the inputs. We did look at this somewhere. I remember using this. But it tells us the inputs for different outputs for different inputs. So if x were 0, the distance from this point to this point would be 2, right? If x were, let's say, -1, we just found it to be the square root of 10. So here, this value right here, if you take the square root of 10, that's what you're going to get. 3.16, that's the distance. Notice all of these are positive because we're talking about distance. So these are just some different ways that this makes sense. So you can see what would happen here as x gets just a little bit bigger in the negatives. It's going to go way down faster. So the distance is going to increase. So that's what's happening. As you get the negative x's, the distance increases pretty quickly. And the same thing with the positives, right? Once we get past this, let's say right here, what looks like it might be the closest. And by the way, somewhere around 1 will be your minimum distance, right? You can look at this and say, well, the closest that this point is ever to this curve is right about there. And that's going to be the minimum. And you can, again, see it probably is 1. I'm not going to find it right now, but just kind of giving you an idea of what the distance curve looks like. And you're going to be doing this for some other functions as well. Okay, I hope you found this video helpful.